few participants. Today is the third day of 1 week online FDP development program on recent tools and techniques for data science and artificial intelligence. And today is the chief guest, Dr. G.N. Vivekananda. I'm welcoming you, sir.
Thank you, sir.
I'm very grateful to introduce today's chief guest, Dr. G.N. Vivekananda, sir. And he is an associate professor in Department of Computer Science and Engineering in Madanapalle Institute of Technology and Science. Sar is having more than 10 years of experience in academics and research works. And before joining Mitch College in 2019, he worked as an assistant professor as an ad hoc profession in JNTUA and is in a CSE department. And Sar completed full-time PhD and M.Tech, B.Tech from JNTUA Anandapramo. And Sar having completed company MBA in IT and systems from ICFAI University. And Sir is a team player and worked for a fact-finding committees, NPA and NAC, NIRF and autonomous structures. And he worked as a BOS member and committee members, coordinator, convener of various workshops and FDPs. Sir has organized more than 5 national events as a resource person and reviewer and chair in the conferences. And the area of interest of Sir is includes networks, security, and then artificial intelligence. Sir published more than 23 papers in SCI and Scopus journals, and he published more than 3 national patents and 1 international patents and 1 book chapters. And he is one of the reviewer in more than 20 Scopus and SCI journals, and already Sir completed more than 150 papers as a reviewer. He is a lifetime member of ISTE, CSI, IETE, and IEI, and then Cryptology Research Society of India, and senior member of IEEE. And coming to the collaboration with industry, Sir completed more than many of the certifications like certified ethical hacker and IBM certified academic associate DB2 9 database and application fundamentals. And Sir is a Microsoft certified educator, Microsoft Office specialist, and Microsoft certified professional, Microsoft technology associate, and Microsoft certified solution associate, Microsoft certified IT professional, and Microsoft certified technology specialist. And in addition to this, he has he has a more than awards and recognition as he received a more outstanding contribution in reviewing from Elsevier publication, and then he received peer review awards from public Babylons, and he received a certificates of reviewing from Whaley also. He received a distinguished researcher in computer networks, the International Research Council on the year of 2020. And Sir received MTC Global Distinguished Teacher in Computer Science and Engineering 2020 in Bangalore. So thank you very much, sir, for accepting the request to our as your chief guest for this today's session. Now I'm handing over the session to you, sir. Thank you.
Uh, Thank you for the brief introduction, sir. I hope so
Thank
I'm audible.
Ah, yes, sir. You are audible, sir. Yes, sir.
Sir. Thank you, sir.
Yes.
A very good morning to all the participants and dignitaries. I'm Dr. G.N. Vivekananda, Associate Professor, Department of CSC, MITS. I'm privileged to start the session. Let me share my screen. I hope so my screen is visible to all.
Yes, sir. Your screen is visible and your voice is also good, sir.
Thank you very much, sir.
Thank you very much, sir.
Yeah, my topic of discussion for today's session is malware analysis using data science. We know that as the technology and access to the internet is growing in today's world, so as the threats and attacks are also growing, there are lakhs of applications using the internet, and there can be many motives behind the different types of attacks also. That is why you can see this is my agenda of today's session. Let us start with what is a basic introduction of malware. That is, we will be discussing what is malware and what malware does, how it enters, and what are the techniques to distribute the malware, what are the components and aspects of the malware. Later, we'll be seeing what are the taxonomy of the malwares and types of the malwares, and how this malware analysis is performed in IoT and Android environments. And finally, we'll be concluding the session with a small hands-on. Starting with the introduction part, we see that as the technology is growing, many applications are also growing very rapidly. This is one of the main reason behind different types of attacks also. And we can see here, if you see the stats that is given in IoT and Android platform in 2017, semantic survey said that nearly 54% of the attacks are increased. And in 2019, 4.18 million Android malwares were registered. And 2021, IoT attacks has increased by 700%. By looking into the statistics only, we get to see very easily that how efficient these malware attacks are nowadays in the technology and different platforms. We can see, let us start with what is a malware. I hope so everybody know, we could have heard about regular terms like virus, worm, right? This is also one of a malware. What is a malware? It is a malicious software. It may damage a computer system and it can take the control of the system completely. The control of a system can be handed over to the hacker completely if a malware enters into a system, if it is not handled properly. And let us see what malware does to your system. It can delete the files, it may slow down your systems, or it may steal your personal information, send the spam mails or messages, and this leads to commit fraud also. Without your interruption, automatically a malware can do many things in your system. And we'll see how it enters into a system. There are various ways that malwares may enter your system, from messengers like Facebook, WhatsApp, or if you try to download any torrent or any file from a third-party websites, it may also download a malware along with it from the emails we get or from the any files from the internet. Even it is getting attached to the softwares. And we see from the insecure patch management, that is, if you don't update your system regularly, if you don't patch your system regularly, it may also lead. It is also one of the reason that the malware may enter into your system. And from the untrusted websites and the freeware, we can't get everything for free. But if you get everything for free, you must know that something is there inside that particular software or a particular application. This is how the malware, these are the different ways that how your malware may enter into your system. And let us see now what are the different techniques to distribute the malware. Normally, we will be using black hat search engine optimization, ranking malware pages, and social engineering, clickjacking, and spear phishing, and malvertising, and spam mails. These are the mostly used 5 techniques for distribution of the malware around the internet. Uh, guys, please let me know. Can you see my screen? Is my screen visible?
Yes, sir. Your screen is visible only, sir. You can continue.
I'm not getting any participants. If you have any doubts or queries, you can stop me at any time and you can raise the question or query, right? Thank you. Okay, now let us see what are the components of the malware. Various components like cryptor. Cryptor malware for it bad. You can't detect whether your system is infected with the malware or not because it's and downloader. That is, it downloads their malware from the internet. I have, I have got a mail. Some exe file is downloaded into my system, but automatically that exe file will download the other malware into the system. That is downloaded, put the target, with antivirus. We call this as a venom also sometimes the drop as a venom. And exploit, yes, this exploit, but it is a part of a malware. And because of this, the vulnerability you can see, and injects the exploits into the target systems. Obfuscator, it conceals the malicious code and backup. It compresses and it will send the data. Payload, it is data that is being used in the targeted systems and malicious code. This is the basic functionality of the malware we can see. Coming to the what are the different aspects that gets disturbed from the malware. A malware enters system, or when a sort of malware, when type of a malware enters in system, it may compromise the confidentiality, the integrity, or availability. That is, the CAA triad may get disturbed because of this malware. If any of these CAA triad gets disturbed also, your system is said to be vulnerable for the malware. Easily attack is possible in your system. That is why we have to be careful to make sure that that CAA thread should not be compromised in any system. Now let us see what are the different taxonomy. And within the malwares based on the classification into three types. It is based on the type and based on the malicious behavior and based on privilege. If you see based on the type, we have different types of malwares as we know already. Viruses, ransomware, bots, scareware, adware. Now, based on the cryptocurrency, we got to see the crypto miner also here as a part of the type of malware. And if you see malicious behavior in the malware, a malware can spread and it can steal the data anonymously without knowing the presence. Right? It can give you a backdoor as a vulnerability, and it can annoy the user also by creating the shortcuts for the user. And based on the privileges, you can see it is based now only three privileges are there: kernel mode, user mode. We can say this hypervisor and hardware or similar modes because hypervisor is similar to the virtual machine. These are the different taxonomy we can see for the malware. Now let's see into the details of it. What are the types of the malwares? Again, how the classifications are there. What is malware analysis? Yes, this is the topic of the day. We're going to analyze the malware based on science technique. Before going to data science technique, I just want to show you the traditional technique of how we can analyze a malware. What is malware analysis? To know whether a particular application is infected with any sort of virus or a worm. We refer this as a malware analysis. For that, we perform reverse engineering of a malware to find where it have come from and what is the particular functionality and the impact of the malware. We are going to see in this malware analysis. If you see there, why we are doing this malware analysis? To know what happened, how it is happened, what is the kind and intent of the malware, and what are the indicators compromise and how the execution is being taking place, and to find the damage, what is the percentage of damage occurred, and to find who is behind this transmission of the malware. That is to catch the perpetrator. We are performing this malware analysis. We get to see types of malware. There are two types of malware normally. Static malware analysis can be performed in two ways. Static malware analysis and dynamic malware analysis. Yes. Is is visible now? Is it fine now, sir? I'll share it again. Fine now? Yes, coming.
2 3 seconds it will take to
Okay.
find
Sorry for the interruption. Yes, we are back again. Yeah, we were discussing here the different taxonomies in the malware, and I have seen what is the need of malware analysis, and they have come. Why you have to perform the malware analysis? Later, we are going to see what are the different types of malware analysis. There are mainly two types of malware analysis and dynamic malware analysis. This both static and dynamic analysis are used to understand how the particular malware works. But there are different techniques and tools for both static analysis and dynamic analysis. Let us see what is static analysis. See here, Features are extracted without executing the samples. In the static analysis, we are not executing it in any environment, but we are checking based on some features like hash value, ngram, opcode strings. We're checking whether a particular application has any malware or not. And this can be detected using antivirus and intrusion detection systems also. And we can perform the code analysis in the static analysis. That is, in simple, analyzes the executable binary code without executing it. To determine the malicious part of the malware is referred as a static analysis. Now, let me show you a brief practical orientation of this static analysis. The faculty can unmute if you have any doubts, and you can ask if you have any queries. I hope so. My Windows system is visible. My virtual box is visible. I hope so. Is my virtual box visible for all? Can any of you please unmute and let me know whether my virtual box is visible to all?
Yes, sir.
Uh,
Visible, sir.
Okay, thank you. I can't perform the malware analysis in my regular system because it has various antivirus protections and firewalls enabled. That's why I just want to show you the how to perform this malware analysis in my virtual box in which I have disabled the antivirus and the firewall. Okay. Let me say I will take one application. The application name is some lab3. The application name is lab3. Okay, this is one sort of exe application. You can see it is an executable application. You can see it is an executable application, and then application name is lab3. I just want to know whether the particular application has any malware or not. For doing to know that thing, I will just run one software called as hash the file. See here, hash my file. I will run this software called as hash my file, and using this hash my file, I can see whether a particular application has a malware or not. How it is possible? Just use this software called as hash my file and try to upload the application to which you wish to check this. Let me say I want to check the application called as lab3. I am uploading this application lab3. I'm opening this lab3 application. If you just double click it, you get to see different properties of this lab3, like what is a file name, MD5 hash, SHA-1 hash, CRC code, SHA-256 and 512 codes. Okay, and what is a path, time, file size, different properties you can see. In these different properties, I just take this SHA-256 code. I'm taking this SHA-256 code, and let me say, I will be going for a website called as Virus Total. Virus Total. I'll be going for this Virus Total. This Virus Total helps you to check whether your system has any virus or not. You can just type Virus Total, search, Virus Total search. That is one of the Virus Total is one of the antivirus mechanism we have. Okay, this is very easily used to identify whether a particular app has any viruses can be known using this one. Just go for search and give the hash code here. Just give the hash code here. The SHA-256 hash code I am pasting, I'm giving here, and try to analyze it. Try to analyze it. See here, if you see here, yes, this lab3 is a malware, and out of 71, 58 places it got affected. It is identified by 58 different antivirus softwares like Adware, AVG, Bitdefender, Komodo, Cynet, Emisoft. These are the antivirus softwares that are identifying that the particular exe executable file is a malware. And you can see here, and few softwares are not identifying. The softwares which are not identifying, you can say these are not good softwares, good antivirus softwares, because it is not identifying a basic malware which 58 different softwares have detected. Okay, this is referred as a static analysis. This is how we are performing the static analysis. I'm repeating just for the static analysis. Can you please let me know, guys, what is the tool we are using for the static analysis? Can anybody please speak out? What is the tool we are using for the static analysis? Can anybody please spell it out? Your faculty, please try to be interactive. I said there are two mechanisms for identifying the malware. That is using one is using the static analysis and one is using the dynamic analysis. And we are now performing a static analysis. I think so. You can see the software name also on the top here. I hope so it is visible for all, if I'm right.
Yes, sir. Visible.
Yes, can you please tell me what is the software we are using for the static analysis? You can see on the top the software name, hash my files. We are using a software called as a hash my files. This is not only the software, there are tens of tools by which we can get to know what is the hash code and what is the signature of the particular virus file. See here, if you see part, we can see there are different tools for malware, static malware analysis. Like you can go for virus scan, PE view, PE ID, radar, Yara, SSD, different assemblers. Disassemblers are also there for letting knowing to know what is the malware present in the particular application. For the time being, we are using one such software called as a hash my file. And how I did it, I just uploaded the particular file. Now let us see one more file for your understanding. I'm taking one more file, lab2, and let me see. Okay, I have seen the properties here. You can see the properties here. I will just copy the code here to physics code, and you can see, here. Just go for virus total. On the top, you can just paste this code and search for it. If you search for it, you can see whether it is a malware or not. Yes, this lab2 is also a malware. This lab2 is also a malware. And how many antivirus sites are detecting it? Out of 69, nearly some 48 sites are detecting this lab2.exe is a malware. But see here, these are all the different software, AdAware, AVG, Alibaba website. Okay, Alibaba software, this is also antivirus, this is also detecting. Lab2 is a lab2.exe that I have uploaded now. It is the hash is a malware. These are all the malware. You can see different details of the malware from where it have come. See here, when it started, when it's been started, and what is the hash of the particular code. Right, and what is the creation time, when it was created? Can you see the created time of the particular malware? It was created in 1972 for the first time. This lab2 was created in the 1972 for the first time. It is still being circulated as one of the dangerous malware. If you observe here, I am not executing these malwares in my host system, Windows 10. I have installed a guest system, that is Windows XP, in my virtual box, and I'm trying to show you. Because by mistake, if I invoke this any of this operation, it may cause a problem for my system. That is why what I have done, I have just created a virtual box and I have used this lab2 for performing the malware analysis. Now you can see here, by looking into this, you can see it is created in 1972. And what are the different versions of it? Lab 1. It is renamed as Lab 1 also. It is renamed as Lab 1 also. And you can see here what are the different types of relations and how it behaves for every different software, antivirus software, and how many communities are registered under this particular malware, everything you can see here, right? This is referred as a static analysis. Static analysis. What static analysis meant by? I'm repeating the statement. Static analysis, by making use of the static analysis, you can detect whether a particular application is vulnerable or not, whether a particular application has any virus or not, whether it is a malware or not. You can detect it, right? By using this hash my file or different tool and using the hash code, you can search in the virus total. There are many such websites to search the hash code also. You can search. Okay, this is referred as a malware, static malware analysis. Static malware analysis. Now, see here, let us go for the dynamic analysis. Dynamic analysis. In the dynamic analysis, we execute a particular file in an environment called as a sandbox. In a static analysis, we don't execute, but based on the hash code, we are trying to see whether a particular file has any malware or not. But when you see this dynamic analysis, we are executing it in an environment called as sandbox. Okay, this is a closed environment and this has many security enabled in it. And this closed system enables the professionals also to see the action, what it performs. Okay, and this dynamic analysis is a behavioral analysis. It executes the malware and identifies the signatures from where it have come, who have created it, from which country it came from. Such details you can see in this dynamic analysis. And there are n number of tools used for the dynamic analysis also, like Prof, TCP dump, TCP view, Vecshot, Memorize, Volatility, Fake DNS, and different sandboxes are used like Cuckoo, Anubis, Panda, Lemon, and Parsa. These are the different tools. We can't see this dynamic malware analysis right now because I have to execute it. Okay, if I try to execute it again, my Windows may get corrupted. My Windows may get corrupted at the time. Okay, that is why we can't. It needed a separate environment for executing this dynamic malware. Dynamic malware, and you can see for I can show you what are the different tools we make use here. See here, we make use of the different tools like PID, PE Studio, PE View, hash my files, Signature Explorer to know what is the signature from where it have come from. Okay, different softwares we can make use of in the dynamic malware analysis also. Okay, now let us see what is the difference between the static and dynamic malware analysis. You can see based on the approach, if you see static, in the static approach, we get to know the application without executing it. Whereas in the dynamic, we execute the file and get to see it, how it is acting. And you can see the static is very fast and it takes very less time, and dynamic takes more because of the different techniques involved in it. In the static analysis, all we can't detect new malware because the old malware hash codes are only analyzed. Whereas in the dynamic, it is very slow, but it can easily analyze what type of malware. Any new malware also can be easily analyzed in the dynamic analysis technique, and it is very time consuming. And let us see what is the procedure to be followed for the malware analysis. First of all, you have to create a test bed. Test bed involves how to perform the malware analysis, what are the tools and techniques and frameworks that you need to take, and parameters you have for a particular application to perform the malware analysis, and which type of analysis you want to perform. You have to decide in period, like whether you want to perform static analysis or you want to perform the dynamic analysis. Because in static analysis, no need to execute it. Whereas in the dynamic analysis, you have to execute in any one of the sandbox and you have to show how the particular malware is performing. And definitely it can't be performed in a production environments. Next, we will see different types of malware detection techniques. We used to follow normally two types of techniques. One is based on the signature and one is based on the behavior. That is what we call it as a signature-based malware detection and behavior-based malware detection. If you see, let us see how this malware analysis can be done in IoT and Android environments. Later, we will see how to perform the signature and behavior analysis. Okay. how we perform the malware analysis in the IoT. We see IoT is one of the main thing, one of the jargon, technical jargon we are using nowadays from the 2K, and it is one of the fastest emerging fields. As per the 2021 stats, malware attacks increased by nearly 700% in the IoT. And nearly there were, as per the 2020 census, 50 billion devices were using IoT. Now, nearly it crossed 1 crore. Sorry, it crossed nearly 1 crore devices are being used for the different IoT operations. You can see here in the figure how the malware attack the different organizations and the systems by losing and by cracking, by attacking the information. It can attack any smart systems like healthcare, banking systems, and smart homing systems, and smart grid systems, and smart cities also. Okay, just if you see, if you have heard about a website called as Shodan.io, this Shodan.io, in which you can see different live cams are being hacked, traffic cams are hacked using this malwares. Different malwares are hacking regularly thousands of traffic systems and healthcare systems also nowadays. Okay, now you see here. This IoT environment is vulnerable for many attacks using devices and smartphones. As per the 2020 census, nearly 20.2 million were affected. And if you see, introduction of edge devices also provides additional attack surfaces for the malware developers. Because as you are growing, the malwares are also growing because of the new technology intervention. I can see how the IoT attacks in the malware has started from 2008 to 2018. That is in a span of some 10 years, different types of malwares are introduced for attacking the IoT devices, ranging from Linux Hydra, Cybot, Chuck Norris, Tsunami, Mirai to the VPN filters to the present date. Okay, there are hundreds of such different malwares that are attacking the IoT nowadays. That is why, as a research topic, malware, IoT analysis, and reduction, how can you find and eradicate this malware in the IoT is being one of the top research topics nowadays. And you can see, based on the malware detection in the IoT, you will see a taxonomy here. In the static method, there are two methods again. One is a non-graph method, and there is a graph-based method. In the graph method, you will see two functionalities to find the malware in the IoT using the function call and using the operation code. By using the operation code is similar to the hash code. Using that also you can find whether a particular application has a malware or not. In a non-graph method, again, it is being segregated into two types, high level method and low level methods. Again, we are finding here using string, the opcode, the ELF header. ELF header is a executable link format header in the, and you can see this is one of the process for detecting the malware in the IoT. We will be making use of the processor. From that is, you can consider first one ARM. This is one of the IoT device. In the IoT device, I will be extracting ELF files, and from the ELF files, I'll be making an ELF parser. That is, I will be extracting the ELF file and decompile it, and I will be looking into the opcode in it. Based on the opcode, now you will be performing the feature extraction. Feature extraction is referred as a dimensionality extraction. You will be seeing what are the different attributes that are present in the particular data set, and you will be extracting all the data set, and finally you will be creating a file feature vector. Based on it, you will be knowing very easily whether the particular classification that we are doing is a malware or is a benign. Benign in the sense it is not a malware, it is not harmful. You can see here Android malware analysis. As we have seen the evolution of IoT from 2008 to the present date, similarly, the Android also has a different evolution in different flavors of the versions. Like we will be seeing lollipop version, Kit Kat version, marshmallow version, different versions of the Android. Okay, we can see here based on the figure from 2010, different types of malwares are attacking this Android also, like fake player, Droid Dream, op fake. Okay, these are the different malwares that are attacking your Android operating system also in different ways. We can see how the malware can be detected in the Android. We can see the flow here. Once I download any application from the Android, okay, all the applications in the Google Play Store, we can trust it because Google Play Store will be first performing all the different types of scans. But for us to perform different types of scans, first of all, we have to download a particular application from the Android, and we have to perform the reverse engineering of the particular app. Reverse engineering in the sense, you get to see what is the code. You can disassemble and decode the particular app, and we can represent this app using three types of features. That is low-level information. You can get the opcode segments, and you can perform the high-level semantic features. That is, if you can filter the data here in the high-level semantic features. And if you want to add, if you want to know anything also, who has created a particular app, who developed the particular app, such information is also available in this app characterization. After performing this thing, you can customize the network structure for the malware detection. You can plot a graph. You can plot a graph using this, and you can evaluate based on the evaluation metrics to find the accuracy of a particular system using true positives and true negatives and accuracy score. This is how we perform a Android malware detection using the ML process. Now you can see here, Android APK collection and pre-processing. Every Android app comes with an extension at present with APK. Right? Earlier apps has .jar and different formats, but at present we can see the Android app. If it is an Android app, it comes with an extension .apk. And if you see Android manifest.xml, what is this Android manifest.xml? It is a configuration file. When we create, let me say, we will be using normally Android Studio. It is Android Studio is one of the applications to create an Android app. When you create an app using the Android Studio, three resources will be created by default. One is manifest file, that is Android manifest.xml. One is a Java file, and one is a resource file. That resource file will be having the view details. Okay, this Android manifest.xml is a configuration file in which you can change the app configuration. To connect to the internet or to disconnect from the internet, what is the theme you are using? Every change can be made in this Android manifest.xml. And you can get these apps from the trusted website Google Play Store. But downloading the apps from the third parties is a risk because they may not verify. And see here, the next topic, reverse engineering for feature extraction. To know whether an app is affected with malware or not, we are performing the reverse engineering. In the reverse engineering, you can clearly extract the code of a particular app, and you can see whether an app has any sort of malware under. Right? We have different tools like APK tool, Dex Compiler. Is an app. We have to characterize whether it has an malware or not. We perform the raw code optimization from the disassembled apps, and based on the classes.dex bytecode, we can see whether app has any sort of malware in it. Okay, you can see here malware analysis using machine learning and deep learning. These are our topic because we are seeing here how to perform the malware analysis using data science. Right? We see that data science is also a subset of the AI here. You can see in AI, we can make use of any technique that enables the computer to mimic the human behavior. And ML, it is the ability to learn without being programmed. And DL, we can see different pattern extraction techniques like MLP, CNN, and RNN. In today's demo session, we are going to see one demo. using two algorithms, Navy base and SVM algorithm, or we'll be analyzing one data set, malware data set. Yeah, this is a definition for the machine learning. It is a field of study that gives computer ability to learn without being explicitly programmed. That is why to analyze normally each and every single application, it takes much time. Right now, to avoid that, we are performing dataset analysis using ML algorithms such that n number of samples can be checked at the same time, and we get to know whether a particular app is infected with the malware or not very easily. Right? That is what we can see. There's a basic advantage, main advantage of the machine learning. When you see the traditional learning, based on the rules and data, we get the answers. But in the machine learning, our rules are formed based on the expected answers and data. In the taxonomy, you can see the taxonomy of the machine learning in the malware analysis. We normally follow three types here. What is the objective? What is the feature to be followed? And what is a machine learning algorithm we may use for it? And you can see objective, we have three objectives. First of all, detect the malware, find the similarity in the malware, and finally analyze the malware. And then the feature extraction, and based on the PE feature, we are going to perform the analysis of a malware. Based on the ML algorithm, we are here seeing three types of learning techniques: supervised, unsupervised, and semi-supervised algorithm for finding the malware analysis. Due to the time consideration, we can't see all these techniques here. I just have taken one example, one data set, and I'm trying to perform two algorithms. I'm trying to train that particular data set and trying to see the results based on the two algorithms for today's session. Okay, guys. Now, let me show you how it is done. See, malware detection using machine learning. This is the thing we are seeing now as a demo. We'll be going to see as a demo. Normally, it's very helpful for classification and clustering of the malware. We can see the major benefit in ML. We can develop a new model for detecting the unknown malware also. Okay, for unknown malware detection, we can use this ML detection techniques. You can see here a framework, a schematic framework for the ML detection. First of all, the training phase. Next, the testing phase. We'll be considering the malware files. That is, we are considering the data sets, and we are performing the classification, whether it is a malware or benign, and we are performing the analysis here. Here we are performing the classification and we are performing the extraction. I am extracting few features from the given data set. I'm training the particular data set using a classifier, my classifier. It may be, and I'm looking the classification. What is the accuracy of a particular model? How much a particular malware is affecting the system? Okay, let us look into this part. Schematic framework. Dear faculty, can you please let me know whether my browser is visible? Can you please
Visible,
let me
sir.
know? Visible, right?
No,
Thank you.
no.
Yeah, thank you. Yeah, if you see here, I have created already a folder in my drive, and I wish to work on two algorithms, Navy based algorithm. It is one of the ML algorithms, SVM algorithms. Let us start with Navy based algorithm. I hope so. In the previous sessions that had happened, you could have listened about this supervised and unsupervised algorithms. That is why I'm directly going for the analysis part without explaining what is base and SVM algorithm. Yeah, I have opened my Colab. Yeah, faculty, please let me know. Is my Colab screen visible?
Yes, sir.
Yeah. Okay. Now the first step is, okay, let me show you the data also. This is the data set I have taken, which has the data set has 1 lakh samples and 35 features. This data set has 1 lakh samples and 35 features. I have 35 different dimensions in my data set. Okay. Based on this, I just want to see the accuracy. See here, for every data set, if you observe here, for every feature, there are 1 lakh samples. For every feature, there are 1 lakh samples. There are 1 lakh samples for every feature. And you can see hash is one feature, millisecond is one feature, classification, state, usage, counter, priority, static priority. These are all the different features of my data set. Dimensions, I can call it as a dimension. I have many dimensions in my data set. Okay, now let's look into the first thing, what we are going to do. I am mounting my Google Drive now. I am mounting my Google Drive now because I have uploaded all the data into my Google Drive. You can see here, I have uploaded my data. The Google Drive. I have uploaded my data in the Google Drive. The folder name I have kept as Talk, and I have kept in the data set. Okay, now what I do first, mount it. I have to mount. So if you do this for the first time, it will be asking for the permission of your Gmail. You have to give the permission for your Gmail to mount your drive. This is the first step. And one more thing I just want to convey here. This analysis depends on your internet speed also. If your internet speed is less, it may take much time. Okay. You can see here, if you get the tick mark, yes, it's see here. Permit the book to access the Google Drive files. Just connect to the Google Drive. First of all, you have to connect to the Google Drive. That is, you are permitting the Colab to access your Google Drive folder. I can consider this classification that we are doing now is a dynamic analysis because when let me say there are 1 lakh apps, 1 lakh samples here. There are 1 lakh samples here. To perform 1 lakh samples, we have to search for the hash code 1 lakh times, and you have to search in the virus total for 1 lakh times. But whereas in the dynamic analysis, I'm performing all the 1 lakh samples execution at a single shot using this algorithms. See here. Now, as I have mounted my Google Drive, I'm importing the packages. You can see I'm importing few packages: the Pandas package, NumPy, Metasploit package, and the Seaborn package. These packages I'm importing after. What are these packages? Can anybody please let me know what are these packages? What is Pandas package? This Pandas package is used to analyze the data. And what is this NumPy package? For the large arrays, matrix, and different mathematical functionality, you are importing the NumPy package. And you can see two more packages, Metasploit and Seaborn. This include the different libraries for plotting graphs interactively. Okay, if you want to have interactive graphs and very good look at the different types of graphs, you can take Metasploit and Seaborn. Metasploit and Seaborn. Next, my next step is I want to give the path. I want to give the path where my data set is located. Just see here. I have in my drive. I am going for my drive. In my drive, I am taking my folder. My folder name is Vivek Talk. This is my path where my data set is stored. Let me give me the path. I will copy this path. I will copy the path and I will give the path name. See here. There is a path. There is a path. After that, you can run it. After giving the exact path, if you run it. If you have given the exact path, it will show you the tick mark. That is, it is fine. Okay. Now, the next step is load the data and get the top 5 values. Load the data set. I'm loading the data set now. See here. I just want to see how many samples are there. You can see the result here. The first step. See here. Load the data. I have loaded the data. After loading the data, analyze how many samples are there, how many features are there. You can see the resultant here. There are 1 lakh samples in my data set, and there are 35 features in my data set. And data head, I just want to print top 5 rows in the data given Excel, given CSV sheet, right? In the data set, I'm just printing the top 5 rows. Top 5 rows. You can see different features. Yeah, faculty, can you please mute yourself? Thank you. Yeah, I'm first displaying the data and I'm displaying the top 5 rows in the given data, right? The next thing you can perform is you have to calculate the number of values here. See here, this. Yes. Now I'm calculating whether a particular data set that you have uploaded has any empty fields. Because a data set that has the empty fields or missing fields is not a good data set. Okay, we have some techniques called as dimensionality reduction techniques. Based on the techniques, we will be following few conditions, like a few techniques are there: pack, feature analysis, auto encoder. Using these techniques, we will be removing such useless variables or dimensions from the given data. Because if missing data there is there in the particular feature, it may lead to few problems when you are looking into the accuracy of the particular model. That is why we are removing such features. Now, using this condition, I'm just looking, are there any missing values in my data set? Let me run it. If there are any missing values, if there are any missing values in my data set, it will be displayed here. Now, if you see here, all the 35 features, I see no missing data values. All the values are zeros here. This zero represents there are no missing values in your features. There are no missing values in your features. Your data set is perfect. It is very clean. Your data set is very clean because there are no missing features in it. Okay. Now, after this, now let me see what are the columns, what are the different features in my data set. I am running data.columns. It will give you the output. What are the different features in it? Your data set has 35 different features. Your data set has 35 different features. See here, 35 different features are hash, millisecond, classification, state, usage counter. These are the 35 different features that are present in your data set. I have retrieved all the 35 features now. Now my next step is, if you have got any missing values in the data set, remove such data sets, remove such features. Do you have any missing values in the features? Can you see any missing values in the features? Can you see any missing values in the features? See here, all the features has the value 0. If any missing value is there, for example, let me say in the end data, 2 values are missing, then it will be displaying 2, but I see no missing values. I see no missing values here, right? That is why if I run this data also, see here, I'm just trying to remove any missing values are there. No, there are no missing values. That is why in 1 lakh samples, again, you are getting some 35 features exactly. There are no missing values. As there are no missing values, you are getting all the 35 features as it is. And I'm displaying, using this command, I'm displaying the top 5 rows, top 5 rows. Okay. Now see here, next statement. How many malware I want to classify now? I want to classify in the given data set how many malware. See here, you can see the classification here. You can see the classification. How many malware are there? How many Binig are there? How many malware are there? How many Binig are there? I want to classify from the given data set. Okay. This is why I am running a condition here. See here, I am running the condition. Data classification. You can see clearly here. There are 50,000 samples malware classification and there are 50,000 Binig classification. There are 50,000 malware and 50,000 Binig classification. That is, in 1 lakh samples, it is equally distributed. Malware and Binig are equally distributed. Now, I am labeling the malware and the Binig. How to label it? See here, I am labeling in the given values. I am labeling 0 for Binig And for malware, I'm giving the value 1. And for malware, I'm giving the value 1. For the benign, I'm giving the value 0. You can see here, I'm giving the values now. If you see the values after classification, now see here, values, all the ones means all the five top values are the malwares. All the 5, 1, 1, 1, 1, 1. I have got all the 5. These are the 5 the malwares. Okay. Now, what I want to do, I want to perform the classification to show a graph. Let me make use of the empty exploit and Seaborn for plotting the graphs here. I want to plot two graphs. Let me say bar graph and a pie chart. As there is equal distribution for both Linux and the malware, you don't see any difference between the bar charts. And you can see here in the pie chart also, there is a equal distribution. There is an equal distribution in the pie chart. 50% of malwares are there, 50% of the benign are there. Now, let me say I want to perform the reduction, dimensionality reduction. Dimensionality reduction in the sense, if you feel a particular feature is irrelevant, you can remove such feature. You can remove such feature from the given set of features. I am removing few features from the feature set. I am removing some 8 features here, hash, classification, truncate from the given features. Okay, I feel these are irrelevant because these irrelevant features may cause your accuracy to go down. Okay, to make sure that you have good accuracy, you must select good features and you have to remove the irrelevant or redundant features. That is why I am performing this dimensionality reduction here. See here, I am removing these features. Now, out of 35 features, how many features are there? 27 features are there. Out of 35 features, 27 features are there. I have removed 8 irrelevant features. I have removed 8 irrelevant features. Now, let me perform the classification again of the data. You can see the classification of the malwares from 0 to 9999. That is total 1 lakh samples. I am performing Navy-based algorithm. I am importing Gaussian. You can see I am importing Gaussian algorithm. You can see here and train test split. Train test split. Okay, if you perform this train test split, normally you will be getting 30% for testing and 70% for training. This is a default consideration we make. When you consider any data set, a data set should be trained for 70% and data set should be tested for 30%. We're performing that here. And here you can observe, here, I am performing the testing size is equal to 0.8. That is 30% is being tested. 30% is being tested here. And random number I have taken some 42. There is no need to take 42 only. You can take any random number, 10, 20, 100, 50, 108, 150, any random number you can take. Okay. And you can see, now you can see, try to observe here. I am executing this algorithm, modern Gaussian algorithm, and it got executed in fraction of seconds. It got executed in fraction of seconds. Because, can anybody please let me know why it got executed in fraction of seconds? Why it got executed? Because Navy-based algorithm, there is no training in the Navy-based algorithm. In the Navy base, there is no training. Training is not done in the Navy base algorithm. That is why you can see here, although I have given for training, in a fraction of seconds, it completed the execution here. Now I am generating what is a predicted model, how the predicted model may look like. How many, see here, these are the malwares and 0 signifies the benign versions, benign files. I am running the model now. I am running the model. You can see the model accuracy as 62%. 62% model accuracy I have got for the particular data set. It is not a very good accuracy, but it is acceptable in the borderline. It is acceptable in the borderline. You can see here, I'm running different metrics like accuracy, macro average, weighted average based on the precision, recall, and F1 score. You can see here for the benign, I have got F1 score as 50%, that is 0.50. And for the malware, the F1 score is 71%. Okay, here malwares are performing. Malware's F1 score is very high when compared to the F1 score of the unaffected, that is benign versions. Okay. Now, there may be a question that how can we improve this F1 score? Is there any chance or possibility to increase the F1 score or accuracy when the malware analysis is being done? Yes, you can improve the accuracy using scaling. We can perform the scaling. That is, you can't expect the high change in the high change in the accuracy, but a slight change you can expect, a slight increase you can expect in the F1 score. This F1 score tells, or this accuracy model score tells how much acceptable your particular algorithm is. Maybe base is acceptable under for 62%, let me say. If you perform one more algorithm, like SVM, if you perform one more algorithm like SVM, and it has got some 50%, it is giving SVM giving some 50% of the accuracy, then you can tell Navy base is performing better when compared to SVM. See here, we are performing the sampling. Here we are performing the analysis for 1 lakh samples. 1 lakh samples. If you have seen the static analysis here, if you have seen the static analysis, for every time we have to perform only for one file. The analysis is only performed only for one file here at a time. But if you see this dynamic analysis, I am performing the analysis for 1 lakh samples at the same time. Now let us perform the scaling and let us see if there is any accuracy increment. Let us see. I am performing the scaling now. I am just adding the scalar factor to increase this accuracy. You can see earlier we have got some model score as 62.98 and F1 score as 0.71. Now let us see. Let us see that if we get any accuracy increment. All the steps are same. I'm just adding. See here. Can you observe here? What is the model score now? What is the model score after scaling? It is 0.6464. That is nearly 64%. If you see the previous accuracy, we can see that it is a 62%. It has got some 62.9, around 63%. Now we have got a slight increase, just 1% increment, that is 64. Right, and you can see the increment in the F1 score also. Earlier it was 71, now it is 72. It is 72% increment. Okay, guys, this is how we can perform the malware analysis using this Navy base algorithm. Not only Navy base, you can perform using different algorithms like SVM. Let us have a quick look on how SVM perform this analysis. Dear faculty, if you have any doubts till now, you can please ask me. Shall we see the dynamic analysis using the SVM, or shall we stop here? Dear faculty, please let me know. I know this malware analysis using data science is not a small topic. We can't discuss everything in a single go, in a single session. Okay, it takes time actually. We can conduct this as a complete FDP because we need to discuss about a number of tools present and number of techniques present, different models that are present in the ML. It takes much time to discuss everything. That is why if you think it's been overloaded, I'll stop the session here. Or if you want to see how the SVM acts also, we can go further. We want to see how the SVM trains and give the results for the given data set. Do you want to see it? Dear faculty, please let me know if you want to see. I can proceed further. Okay, right. I'm stopping here. I have just explained you how the dynamic analysis can be performed using this Navy base. Similarly, you can perform this analysis using the SVM and different algorithms also. Okay. Okay, guys. I am stopping my session by here. If you have any doubts in this malware analysis part that we have seen, you can just ask me. If you have any queries, you can write in the chat box, or you can unmute and you can speak.
Dear participants, kindly interact with the resource person. Kindly utilize the opportunity to learn.
Dear faculty, if you have any queries, please let me know.
Dear participant, if you're having any queries, kindly put in the chat window, or otherwise you can unmute yourself and then you can ask questions. Our resource person is available now, so you can ask questions.
Okay, Muthu sir. I hope so. There are no queries. If there are no queries, shall I close the session, Muthu sir?
Yes, sir. Yes, sir. No issues, sir.
Okay, sir.
Thank you. Thank you very much for this wonderful session, sir. And
Thank you, sir.
thank you very much for the participants for attending this wonderful TP. And today's evening session, Dr. Vivekanandan sir going to take. So all are requested to join the session by 6 o'clock. Thank you very much, sir. Dear participants, I will post the feedback link in chat window as well as on our WhatsApp group also I will share. Kindly fill the feedbacks.